Hi, this is Abdulaziz Khan. If you see the lecture number, it's a bit peculiar. I mean, it's 6A. Basically, when I made the lecture 6 and I went through the lecture again, I find that it's not answering up to at least some level. So I thought, no, I should make it a bit more explained. So then I make it number 6A, that it's addendum of lecture 6 is not a different thing. Like, it's not a lecture 7. So it is the lecture 6, but some part is further explained so that it is easy for understanding. So let's see. So some explanation you will find here. You remember when I was showing with my palm that the power density increases. But then I found this one beautiful picture on Wikipedia. So here, if you see this, just let me see if my pointer is here. Yes. So if you see, this is the source. If you see this S, there's a blue light in every direction. So that's why we called it isotropic. It's a single source which is uh, giving power in all the directions. But because we know that the antenna could be in any one of the direction, so that's why we take only one projection. If you see the projection, so for example, the power is, for example, 1 at this point. The same power will be then be inside in this square. The same power will be here, whatever was here. Now, whatever power is within this part, when it will come at a distance of 2r, like it traveled from this from here from point 0 to some distance r, and it comes to 2r, the same power which was in 1 square will be in 4 square. So the because this was 1 square, now the area becomes 4 times. So the power of each square is now 1/4 because the total power will be the same. We are saying that the same power is transmitting from here to here. So as the distance increases, the power uh, reduces with the square of the distance. When it reaches 3r, this I find it very nice. I mean, it shows 1, then 4, and then 9. So you can see that each of this square now has 1/9 of the power. So that's how this is the d. This is the d square. So power spectral density, the power is getting reduced by 4 pi and d square. So this is how we try to understand it in our mind. And the power at any specific square, like we assume that if the square has some specific value, but if the square has a different value, then you will simply multiply this power spectral density which is coming out of this with the area, the actual area, because we don't know it will be on 2r or 3r, that is a different thing. But again, we don't know that how much of this, like for example, we are assuming that you will take your antenna may be a very small part of this square. So basically you need to know the area of incident, how much power you will be getting. So the receive power will be spectral density into area of the receiver. So area of the receiver is also very important. So this I was thinking that it was lacking. I don't know because I don't get a lot of these kind of comments, and it's not a physics lecture as well. But still, I mean, I don't know if everyone has got the understanding, but I feel that this was a very simple understanding that the power is transmitting from one point and it's going in a direction, and power spectral density we have. So the receive power is power spectral density into the area on which we are observing the power. Okay, let's go to that part where we say that some equations they will meet and then they will give you the final value. So here we have, as we saw, that receive power is power spectral density into area of the receiver. Power spectral density, we know that S is equal to Pt oblique 4 pi d square. Area of the receiver, we know that it is based on lambda, lambda square by 4 pi. Now what we do is that this is the same PR. We put the value of S from here. This is the value of S. We put it here. This is the value of AR. We put it here as well. So this AR is coming from here. Now what we will do? This we will do some rearranging here. And how we will do rearranging? Because at the end we need the power transmit by power receive, because that is the loss that we have. So power receive, we will take it to the downside, because we need power transmit by power receive. So power receive will come to this point, it will replace this and it will come on at this place. This 4 pi will go to the upside because it is down. This lambda square will go down here, and this 4 pi d square will also go up here. Now if you see, this also has a 4 pi. You see these two, this has a 4 pi, has a 4 pi d square. When these two will be multiplied with each other, basically we will have a 4 pi d whole square, because 4 pi is now also twice of the time and d is already squared, so it will be a square of 4 pi d. So what it will happen, how it will transform at the last, as I told you that PT was up, it will remain up. This PR will come down. So on this side, only PT divided by PR will remain. Everything else we will shift on the other side. This 4 pi and 4 pi d square, they both will go on the upside. They will come here. As I told you, d was already squared and 4 pi was a single time. The second time will come from here. It will become a 4 pi d, and this lambda is already squared. So divide by lambda and the whole will become n square. So this will become our free space loss equation. Now what will happen is that we will take all the constant value, because this is the same thing. One thing that we do is that we change lambda with c oblique f. We know that lambda is equal to c oblique f. So when we will put lambda here, it will become c and f will go up. So it will be c oblique f. And then what we will do is that we will take all the constant values separately, and the two values which are variable, f square and d square, will come outside of it. So we will just rearrange this one, and because when we have to show it as a dB, as I told you that generally we don't show it as absolute power, we show it as a relative power, which is in decibels. So to make something in decibel, we make it like 10 log of 10. Logarithmic base 10, we take the logarithmic base 10 of the value and then we multiply it by value by 10, so it becomes a decibel value. So when we try to do this, I have tried to open it. So this 2, because this is a square, it will come outside and it will be multiplied with this whole. So this will become 20 and this 2 will be gone. 20 log of 10, 4 pi df oblique c. Now we will separate the d and f. So 20 log of d plus 20 log of f, these are the two constant values, plus 20 log of 4 pi oblique c. This was one of the questions that I have left open. If you remember, our main equation was 92.4, because I told you that this is because we have a kilometer and we have a gigahertz. If we have something else, then it will not be 92.4, it will become something else. So, but when here we open it, it is 20 log of d plus 20 log of f, 147. This is minus 147, it's not plus 92. So one thing that we did not explicitly mention, now I'm telling you, because we did not mention that how distance and frequencies are being taken here. So, but as we did not say anything, they were in the empirical values. So distance was only in meters, because when you don't say anything in a equation, so distance is in basic numbers. So distance was in meter and frequency was in hertz. Now we will add to meter, to change it to kilometer. 1 meter has 1000 meters. So you have to add a 20 log of 10 raised to the power 3 component in it. This will change the meter into kilometer. Same like frequency, it's in hertz. Gigahertz is 10 raised to the power 9 hertz. So we have to add this value as well. So 10 log of 10 is basically nothing, it's 1. 10 log of 10 is 1. And as we did here as well, or anywhere, whatever is the power, it should be multiplied with this value. So this value will become 60. 3 will be multiplied by 20, it will be 60. Log of 10 base 10. This will be 180, and this will also be log of 10 base of 10. So the number here will be 60 plus 180, which is equal to 240. When we add this 240 to this minus 147, so when this 240 will be added here, it will become the 92.45. So if you remember, this was our final equation. So I thought to give it to you fully so that there is no doubt. Hopefully you will be understanding it now. I try to keep it simple, fast, and up to a simple value, not in very much detail. The previous one, I thought that it has a bit of caveats. Some people will need some more time. So I thought to explain it. I hope you will like it. See you in some next video. Goodbye.